11 methods. We're going to look at question 1e from exercise 5b. Okay, so we want to sketch the graph of each of these and find the domain and range. Okay, so this graph is saying that the graph such that it follows a set of ordered pairs such that it follows the rules x minus y equals to 4, and x can only be between, or x is a member of, -1 to 2. Okay, so we've got a restriction on this graph. Now, x minus y equals to 4, that should ring a bell because that's just a linear graph, okay? It's just in a form that we don't really recognize. So to make it more recognizable, if I move the y to the other side and I move the 4 to this side, then we know that's like the y equals an x plus c form. So it's a linear line. So my y-intercept is at 0, -4. My x-intercept, if I let y equals 0, then x equals to 4. Okay. So normally your graph would look like this. -4 and 4. Okay. Now we don't have the normal graph. Why? Because there's a restriction on the domain. It's not wanting you to have a full domain. So what you're going to do is you're going to cut it short. Okay. So your graph is going to start at when x is -1 and stop at when x equals to 2. So you're going to have a short section of the line only. So let's find out what the values are as the endpoints. Okay, so when x equals -1, my y value equals to, we'll find out what it equals to. We just sub that in. So I'm going to sub into the original equation, or I can sub in this one. So when x equals -1, -1 minus 4 equals y, so y equals to -5. Okay, so this would be -1, -5, and when x equals to 2, sub it in. So 2 minus 4 equals to y, so y equals -2. So 2, -2. So we've got our two coordinates. I can find my domain range. Now, domain is actually given to us because the original question actually tells us what our domain is. So the domain would just be -1 to 2. Okay, and you can see clearly that's the case. We're going from -1 for the x to 2 for the x. Okay, the range is how high it goes, and like what's the lowest value, what's the highest value for the y. So my lowest value is -5, my highest value is -2. So my range is from -5 to -2. Okay? You always go from the lowest to the highest, domain and range. Okay? Next question. Question 6, sketch the graph of this. Okay, state the range. Now this is a very straightforward graph because we've got y equals x squared plus 1. That's a quadratic that's been moved up 1. So it's going to look something like this. Okay? Now, it's turning points at 0, 1. So my range would be, what's the loss value? My loss value is -1, not -1, +1. And it goes up to, it goes up forever, so it goes to infinity. That's your range. Okay? And your domain is obviously real quadratic. Okay? Question 7, I want to do C. Now, question A and B are easy because they're already in circle form. Now, this is not entirely in circle form. The reason why is because there's 2's in front of the x and y's, so you've got to take it out. It's like taking a factor out. So I'm going to take a factor of 2 out, squared, plus, that should be a half, because we're going to take a 2 out, that changes to a half. 2y minus 2 squared equals to 1. Now, I need to take the 2 out, so in order to take it out of the brackets, I have to square it. So that comes 4 x minus half squared plus 4y minus 2 squared equals 1. I need to get rid of the 4, so I'm going to divide every term by 4. And I can do that because I'm doing it to every single term. Okay, so 1, I need to do it to the other side as well. Okay, now it's in circle form. Okay, so the center is at a half, 2, and the radius is the square root of a quarter, which is a half. Okay, so I'm going to draw the graph. So I'm going to put my a half 2 here. Now, if I go a half this way, then we're at the 1 set. Okay, so this would be 2. If I go half this way, and it's not that proportional, if I go half this way, then there'll be 1, 2. If I go half up, there'll be 2.5, a half, 2.5, half, 2.5. If I go half down, then there'll be a half, 1.5. So I draw the circle, I'll just put it here because that's not the correct point. So my domain would be what x values it can take. What's the loss x value? So if I look at it from the x perspective, the loss value would be 0. Okay, and the highest value would be 1. So it goes from 0 to 1. Okay, so it spans from 0 to 1 for the x. The range for the y values, the loss value for the y is 1.5. So 1.5. Or I think the book might write 3/2, and that's okay. Same thing. 1.5 and 3/2 are the same thing. Or 2.5, which is 5/2. Okay, so 3/2, which is the loss value, and the highest value is 2.5, which is 5/2. Okay. So hopefully that gives you an idea. And implied just means what's the natural domain. Okay, because it's a circle, it's obviously not going to span the whole number line because it's by its nature doesn't go everywhere. It's just fixed. It's very contained. So we're just wanting the natural domain of the graph. Okay, and that's your domain range. Question 8. I want to sketch the graph of that graph. Now, with these graphs, always remember if you have a number in front of the x, you always have to take it out. If it's a negative or a number, but you take both out. Okay, so I want to take out -2, put x there, and that becomes -5/2. Okay. The reason why I would do that is because I can't tell the true left-right shift, the left-right transformation, um, if we don't do that, okay? Because the graph hasn't moved, 5 to the left. That's not correct. It's actually moved 5 and 2 to the right, okay? So, and also we've got a reflection, okay? Reflection in the y. So our original graph looks like this, but it's reflected in the y, so it looks like that. Okay, so that's the shape, and it's obviously moved 5/2 to the right. So 5/2, like this, and it's going to have a shape looking like that. The y-intercept would be when x is 0, so y equals √5. Okay, so my domain for this graph would be from -infinity, because that's my loss value, all the way to 5/2, including. Okay, my range, you're starting at 0 for the y, and you go up, and this graph is increasing forever, so it goes to infinity. Okay, for e, so this is for the first graph. For e, this graph, you've got to be careful. Again, we've got a scenario where we have a number in front of the x, okay, and we need to know how to deal with that. And that's okay, just take it out as a common factor. Okay, you got to take it out inside first, okay, so don't jump the gun and put a 2 at the front, very front. That's not correct. It's still inside the bracket. You have to square it. Okay, so it's 2, 4 on x minus 5 squared. Now, I can still simplify because 2 and 4 go into each other. So 2 to the 2 once, 2 to the 4 twice, minus 5 squared. Okay. Now we're not done yet. I want to sketch the graph, okay? So when I sketch the graph, I know that this is a truncus, and we've got asymptote at x equals 5/2, okay? And it's a truncus shape, so we're just going to find the y-intercept. We're not going to have x-intercept because Does it ascertain y equals 0? Okay, so all I need to do is find the y-intercept. So y-intercept x equals 0. I'm going to sub in its original. Sub it into the original. Okay, let's go back to that, to the original. So y equals 2. Now if x is 0, that goes away. So left with negative 5 squared, which is 25, 225. Okay, so 225, so the graph is going to look something like this. Okay, I'm trying to make sure my shape is good, because I did penalize people on poor shape, so I've tried to be a good model in drawing a shape. Okay, so this would be 225, and the other part would be yeah, you only need that part. Okay, so if you want to be pedantic and find the second point, and you should find second point when x equals, say, is 1, then you got 2 minus 5, which is 3, 2 minus 5, which is negative 3. Negative 3 squared is 9, so 2 over 9. Okay, so 1, 1, 2 over 9 as the second point, and what I'm doing now is I'm just finding the domain range. Okay, so my domain would be any number, because this goes on forever. This goes on forever this way, this goes on forever that way. They cannot touch the asymptote at 5 over 2. So domain is reals, excluding 5 over 2. The range would be all values. The range, not all values. The range cannot, can you see it cannot touch y equals 0. So it's starting at 0 but not including 0. It's starting at 0 but not including 0. But it can be any value because it goes up forever. Okay, so this goes up forever and ever and ever. So what's the way to write 0 not including 0 but goes up forever? It's just real positives. Okay, r plus. So r plus just means any positive number, which makes sense because 0 is not a positive number. So if you exclude 0, but it could be any value other than 0 that goes up, it must be real positives. Or if you write something like 0 to positive infinity, that's correct as well. Okay, but usually we write r plus in place of that because it's an easier abbreviation. So hopefully that helps you or answer some of your questions. I think some of the questions were tricky simply because you need to know how to take the factor out first before doing them. Okay, so like this question, you need to take the factor out. Otherwise, I think that should be okay. Question 3C, I think I've already done a video on that, so please check the Google Plus site.